This graph represents the data collected by our team for the experimental treatments at 1%, 3%, and 7% concentrations, as well as the average class results for the control at 5% concentration of glucose. The best way to summarize our results was to plot the average rate of fermentation as a function of the glucose concentration. This graph shows a higher rate for the treatment at 1% concentration, which indicates, quite surprisingly, that the fermentation was more effective with a lower concentration.
It is easy to see that the solution with the lowest concentration of glucose used in the test is the one with the highest average rate of fermentation. This is surprising because usually a higher concentration of reactants leads to a faster reaction.
This unexpected conclusion might be due to the inhibition that sometimes happens when the reactant concentrations are too high. However, when comparing with the results of the two other teams, we see that there is a peak in their results at 4% concentration. Since we did not test this concentration, more experiments and more testing would be necessary to reach consistent results.
That has already been done is enough to show that higher concentration of glucose does not equal better rates of reaction. Therefore, to optimize the production of ethanol biofuels, low concentration of glucose should be kept, as this gives the same results than when high concentration of glucose are used.
The glucose used in biofuels industry comes from cornstarch that is being broken down with enzyme. Hence, if the solution obtained from this reaction was to be diluted, the results might be improved and the corn needed would then be reduced.